Hey, if you'd like to earn CEUs for this webinar, join the Safeopedia community at the link in the description below. Now on to the show.
Well, I want to welcome everybody to today's webinar. My name is Scott Cuthbert. I'm co-founder of Safeopedia, and our mission is to support and uplift safety leaders with the knowledge, resources, and community they need to help them make workplaces safer. So before we get into the webinar, I just want to thank you for the work that you do, keeping people safe. It's often behind the scenes, a thankless job some days, but our families, communities, organizations are profoundly thankful for the tireless work that you do as safety professionals. So today's webinar is maintaining your gas detection program within chemical manufacturing industry. And I can guarantee you, whether you're an expert at chemical manufacturing or gas detection, or whether you're just beginning your journey, you're going to learn something today because this webinar is made possible through the support of GFG, a preferred manufacturing member of the AD Safety Network and a longtime supporter of Safeopedia. And the presenter today is Bob Henderson, president of GFG, and I can guarantee you, like I said earlier, that you will walk away from the webinar with some new information, new insights today, because there is no deeper, more knowledgeable expert, I think, in the industry than Bob. So today he's going to dive into managing compliance, dive into managing compliance, personnel, and equipment within the chemical manufacturing industry. So with that introduction, I am going to turn it over to Bob.
Thank you very much, Scott, and thank you everyone who has signed up for the webinar. I am a chemist. If you're a gas detection manufacturer, you're dealing in chemistry 24 hours a day. It's what your instruments do, what you do. And if you like chemistry, then almost certainly one of your favorite television shows of the last 20 or 30 years has got to be Breaking Bad. Now, Breaking Bad, it's very clear that under no circumstances would anyone wish to promote the idea of manufacturing and selling illegal methamphetamine, but the show itself, boy, it is just full of examples of what to do and not to do when it comes to dealing with business and customer issues. One of the central points of today's discussion is to make sure and how to make sure that the gas detectors that you're using are fit for purpose. There is nothing easier to do than to buy the wrong instrument, to use it improperly, to misunderstand the limitations of the product. And when you get something of this kind wrong, you actually can wind up putting workers or yourself or your program or your company in danger. After all, gas detection equipment is used to keep workers safe in potentially life-threatening, dangerous environments. So fitting the product to purpose is really a central requirement and super important. And when things go wrong, you can kind of wind up like Walter White. And why did everything go wrong for Walter? Why did he not succeed at the end? Basically, it all came down to communication. Fundamentally, Walter thought he knew more than his customers. His customer communication skills were lacking. The discussions that they had tended to be one-sided. The solutions that they came up with were not optimal, to say the least. And at the end, Walter did not survive for a sequel. That honor belonged to Jesse by himself in El Camino. So one of the things that is at the heart of today's webinar are questions that you should ask yourself, should ask your vendor, should ask your program administrators. The better the questions you ask, and the better job you do listening to the answers, which is also of fundamental central importance, the more optimal solution that you're going to come away with, the best results. And this is your organization, my organization. We are all a performance driven, working for performance driven operations, and you want to make the best, most profitable, most reasonable decisions that you possibly can. So that's what today's webinar is going to hopefully help you out with. Now, when it comes to the chemical manufacturing industry, it's hard to talk with a broad brush that will be correct equally for every kind of chemical industry site and enterprise out there. It's a very broad category. But if you are a vendor, make sure that you have researched and learned as much about your customer as you possibly can before you get there. You don't want to waste time unnecessarily. Learn what you should have learned beforehand. So prepare for the meeting. Your time is expensive. Your customer's time is very expensive. Don't waste it, but also make sure that you take advantage of that time together. Both sides of the desk need to ask good questions and to listen to the answers. After all, if you're an end user, you have invited that sales professional into your office for a purpose. You clearly have enough trust in that individual to want him to be on the premises. So presumably what that individual is about to discuss is of importance to you both. So the good conversations involve sharing and asking questions and listening to the answers on both sides of the discussion. You can't have a one-sided concentration, conversation. So as an end user customer, it's also important that you look inwards a little bit. You need to have a detailed grasp of the gas detection activities and risks that are going on and exist at your site with your business. The better the understanding that you have, the better the solution. If you make changes or buy new equipment, you're going to come away with in the future. And it's sometimes, I know this for myself. If you find yourself in a corner offices can be an isolating experience. It sets up barriers between you and the people who actually work for a living. So leave your office, talk to your employees, whether you're a mid-level manager or an upper management executive. Make sure that your communication and your questions flows up and down the chain of command. The more detailed grasp you have, the better. Drill down to make sure that you understand what is most important, and not only to you, but to the people who are using gas detection equipment on site. Make sure that you verify that you are currently meeting all mandatory and good practice requirements. Try to figure out where you need to make improvements, conduct a gap analysis, and remember that gas detection issues are not necessarily limited to safety. There are a lot of different kinds of gas detection requirements. You have personal exposure, industrial hygiene, emergency response. The list goes on, and we'll talk about a lot of those categories in the next few slides. Here's a starting list. A lot of times, vendors will focus almost completely on confined space, and boy, oh boy, do you find a lot of confined spaces and confined space entry programs at a chemical plant or in the chemical industry. It's definitely a major and important way that instruments are used, but that's not the only category of use. Personal exposure monitoring, you may need to document that your workers on site are not being subjected to any even momentary exceedances of permissible exposure limits for, say, H2S. Every person on site might be required to have an H2S meter, for personal monitoring and exposure documentation. You might have a program that requires you to download the logged information on a regular basis, to use that information to prepare a report that goes off to OSHA or your state Safety and Health Administration office. You have hot work. Sometimes the hot work is in a confined space, which is a double whammy when it comes to introducing potential hazards. Hot work deliberately introduces a source of ignition into the area, whether the area is open or in a confined space. Sometimes as you heat material, you can increase the likelihood for the release or generation of vapors or gases that can be explosive or toxic. You, in the chemical industry, almost by definition, you're dealing or manufacturing or using or producing toxic materials, gases, and vapors. So a lot of times in the chemical industry, you're focused on a specific chemical that you need to measure or monitor or control. You have hazmat and emergency response. You have all sorts of other activity-based monitoring. In other words, there are a bunch of different gas detection objectives and requirements at a chemical manufacturing plant. The manufacturing gas detection requirements can include production monitoring, process monitoring, facilities monitoring. Nobody wants to lose $150 million complex or $1 billion chemical plant in some cases. Sometimes it's industrial hygiene, sometimes it's community, such as a fence line or nuisance odor monitoring system. Sometimes the requirements are driven by EPA requirements, disaster response, and of course, construction. At a good sized facility, there's always at least a little bit of construction going on. And during major renovations or updates or shutdowns, there can be a lot of construction going on, which leads to additional unique hazards and considerations, such as confined space entries that go on for a couple of weeks instead of a couple of hours. Organizationally, it makes quite a bit of difference. And communication gets much more important. It's always important, but boy, when you have different contractors present doing different jobs at different points in the construction process, that introduces some pretty significant challenges. So a lot of different missions, a lot of different activities, many of which are dependent on the use of gas detection equipment. For confined space, you have routine entries, large scale ongoing entries, entries into inerted vessels. What is an inerted vessel? Well, to reduce the chances for an explosion occurring, you might want to flood a confined space with nitrogen. So you replace any oxygen that was in the confined space atmosphere with nitrogen and reduce the chances for an explosion occurring because there's no oxygen, one of the necessary components for combustion or a combustion explosion to occur. Hot work, other specialist procedures like catalyst rebuilding. Catalyst rebuilding is often done on under a purge of nitrogen. And if you're a worker who is inside a catalyst tower, rebuilding and repacking the catalyst under a nitrogen purge, that's an intimidating situation, but it's done every day by experts. Not only do you have an issue with the respiratory protection that's required, which is pressure demand, airline respirator with an escape cylinder. Not only do you have to have the respiratory equipment under control, but the um, gas detection equipment that you are using, if you're measuring the gas in the direct area where the worker is doing his job in the inerted atmosphere, that gas detector has to be capable of being used without the presence of oxygen either. So again, fitting the instrument to purpose is a constant ongoing issue, and it merits quite a bit of thinking. And if you're a rescue or confined space response team, holy smoke, you could get drug into any of these types of confined spaces during rescue activities, and you better not do it in a dangerous way. 2 out of 3 of the people who are killed in confined space accidents are would-be rescuers. So you're twice as likely to be killed in an event in a confined space as a rescuer as you are if you were the original worker getting into trouble. What are the most common chemical hazards, gas hazards that you run into at a chemical manufacturing plant? Well, first and foremost, it's so darn easy to get an oxygen deficiency. You can get it by displacement with a heavier than air gas or vapor. You can have rusting, you can have combustion, you can have reaction. Sometimes it's materials that cure in air, some such as sealants and paints, where they actually take oxygen out of the air as they are curing and drying. There's just a bunch of different ways that you can come up with an oxygen deficiency. And you also have microbial action. Microbial action, if there's some organic material around, is an excellent way of dropping the oxygen concentration. For instance, if you have crude oil, one of the first things that you'll notice if you're monitoring the oxygen concentration is that oxygen using bacteria and microbes do their job more rapidly than the other kinds of microbes. As soon as the oxygen concentration is really low, then you see other types of anaerobic bacteria and microbes beginning to do their thing. The anaerobic bacteria and microbes don't consume oxygen they metabolize sulfur substances, and the byproducts that they produce are including hydrogen sulfide, which is a very dangerous, deadly gas that many to most of you know very well, hopefully, and if you don't, learn, please. Anyway, oxygen deficiency is easy to come up with. Oxygen enrichment is a little bit less likely, but can never be overlooked. The easiest way that you can get an oxygen enrichment situation, besides a specific chemical reaction going on that produces oxygen, a lot of the enrichment accidents that occur, especially in a confined space over the years, have been when some unauthorized individual decided to ventilate or introduce pure oxygen into a confined space. And in an enriched atmosphere, materials that might not even burn at standard concentrations of oxygen can burn explosively. And you also have a wide variety of combustible gases that could be present. So typically what you'll see is at many plants, minimally every person at the plant will have a single sensor instrument for a dominant hazard like H2S, or it could be a two sensor personal instrument if there's more than one hazard, or it could be a compact four sensor instrument. You know, it's hard to find an environment at a chemical plant, not talking about confined space, but just walking around the plant, if you have the potential for H2S. H2S is usually a component of atmosphere that has the presence of other hazards. So a lot of employers, a lot of facilities have just taken the approach, you know, we know that we run into H2S, CO, oxygen, and combustible gas. We can run into those four categories of hazard at any time, anywhere on site. So we'll just measure all four all the time. So a lot of the at a lot of the facilities where in the past workers were equipped only with an H2S clip, today they're equipped with a two gas instrument or a four gas instrument, which is mandatory to get through the front gate. Special activities might involve a five gas instrument that adds a PID, a photoionization detection sensor for VOC measurement. Sometimes you have instruments with 6 or 7 channels of gas detection information. It all depends on what's going on and what kind of hazards that you're dealing with. Watch out for hydrogen. Hydrogen tends to be a quietly pervasive hazard that is encountered at a lot of different chemical plants. Petrochemical plants produce olefins and aromatic products by cracking petroleum fractions, and you use hydrogen in the cracking process. You take a big molecule, you crack it into little pieces, you reassemble the pieces into different molecules that actually are the products that you intend to sell. Chemical plants produce ammonia by using natural gas to produce hydrogen, then using nitrogen to produce the ammonia. Gas detection for concerns for hydrogen, first of all, it's colorless, odorless. Even when it's burning, you can't see the flame. And IR infrared LEL sensors cannot detect hydrogen, not now, not some of them, not any of them, not ever. H2 also interferes with CO sensors. Most manufacturers, like GFG, use what we call hydrogen nulled CO sensors to detect CO. The hydrogen null CO sensors have a low response to hydrogen, but it's not zero. The best that anybody does with a reduced hydrogen sensitivity carbon monoxide sensor has a 5% or thereabouts relative response. So if you have 100 parts per million of hydrogen in the atmosphere where you're using that CO sensor, you'll get a reading of about 5 ppm. So by the time that you reach the minimum concentration of hydrogen that supports combustion, which is 4% volume or 40,000 parts per million, you'll definitely get an alarm on the CO sensor. You won't know exactly what caused that alarm, but at least you're not running completely unprotected. But you should be aware that hydrogen can affect some of your other toxic gas sensors. It definitely affects CO. If you don't have a hydrogen nulled CO sensor, a standard CO sensor can have a response of up to 40%. So instead of seeing 5 ppm in 100 ppm of hydrogen, you'll see a reading of 40. If you have a Koch sensor, Koch sensors are dual channel combination CO and H2S detecting sensors. On the inside of the sensor, you have two capsules. One side, you measure CO, the other side, you measure H2S, and the gas goes into the H2S section of the sensor first, and it migrates or diffuses into the CO section of the sensor second. So it takes a little longer to get to the CO part of the sensor than to reach the H2S part of the sensor. And the filter cannot be internally protected by using sensors that will absorb interfering gases like the H2S, or you're not going to get a valid reading on the H2S side of the sensor. So in the case of Koch sensors, you can have cross sensitivity to hydrogen because you don't have protective filters in the sensor that can be higher than 40%, even 50%. So be aware if you have hydrogen, dig into that and find out. If you have hydrogen and you want to use an infrared LEL sensor, that's often a great idea, but you probably want to add another substance-specific sensor to measure the hydrogen so you have an unambiguous indication when the concentration is becoming dangerous. The nature of the hazards dictates the type of equipment that you should consider using. And the way that you find out limitations is by asking questions. Mr. Salesman, will that type of LEL sensor, I've just heard you tell me how low the power consumption is. It's a great sensor, I don't doubt. How will it respond to hydrogen? If you don't ask, nobody's going to tell. Make sure that you understand specific hazards that you have at your site that force you to look at them separately. Some sites it's chlorine, ammonia, SO2, NO2, benzene. Benzene's a big issue at a lot of sites nowadays. for corporate policies that follow the ACGIH TLV for benzene, the latest limit that went update to the exposure limit that went into effect in 2025, you now have an 8-hour exposure limit of only 20 parts per billion. That is pretty dang low, and you might need additional direct reading instruments on site that can directly measure benzene, or you might need to use your photoionization detector, like the one in the taller of these two instruments, that measures total VOC, and that includes benzene as well as everything else. And you take action based on the total VOC. There's no such thing as a non-toxic VOC. You just have some VOCs that are more toxic than other VOCs, and you need to take action to ensure that workers do not exceed the exposure limit for any toxic molecules that are present in the air. Carbon dioxide is commonly encountered all over the place. Carbon dioxide is produced by combustion. It is a lot heavier than air. If it's present, especially in a confined space or a trench or anywhere that in which it can collect, the concentration gets higher and higher. The carbon dioxide displaces the oxygen. If you're only measuring oxygen, it takes almost 67,000 parts per million of carbon dioxide to displace enough oxygen for the concentration of oxygen to reach the alarm setting of 19.5. 19.5 and below, the air is oxygen deficient, and you're starting to see oxygen deficiency symptoms. To get only to 19.5%, it takes 67,000 molecules or parts per million of carbon dioxide in the air. Well, the toxic exposure limit for carbon dioxide is 5,000 ppm. The immediately dangerous to life and health concentration is only 40,000 parts per million, 4% by volume. So if you're waiting for the oxygen meter to tell you if it's safe or not safe from a carbon dioxide standpoint, you're being exposed potentially to a very high, very dangerous concentration. And carbon dioxide is a toxic gas. It can asphyxiate you, but it can also cause permanent harm as a function of its toxic characteristics. So if you have CO2, you really should consider adding a CO2 sensor. In fact, just this year, the International Maritime Organization, IMO, updated their standard for the use of shipboard gas detectors. And the latest version of the standard says if you are measuring LEL, you shall measure oxygen and carbon dioxide at the same time. So in effect, they're saying there are darn few applications where you can get away with less than a 3-sensor instrument. If you have oxygen, you presumably have, as an issue, you presumably have carbon dioxide as an issue, and there's a very few shipboard confined spaces where you don't have combustible atmosphere as an issue as well. So the new requirement is to universally measure all three at the same time. Hydrofluoric acid, HF, is a hazard that I used to only talk about a little bit. Many chemical plants use catalysts or catalyst systems that can generate or include hydrofluoric acid, HF. And at a decent sized chemical facility, you might have a requirement for one or two HF sensor equipped instruments. So that's not a tiny amount of business for a gas detection company, but it's not one of the what you would call the high selling products. That has really changed. The world is becoming dominated by lithium ion batteries. You have at many industrial sites, you have massive emergency industrial battery systems that are based on lithium ion battery cells. You have automotive batteries, you have battery recycling, you have lithium ion batteries in your forklifts. They're just all over the darn place. The problem is, as I think almost everyone knows, when you are recharging the lithium ion battery, if anything goes wrong, you can create a localized short within the battery that causes that area to heat. As the heating of the battery increases, the shorting gets worse, which makes the heating worse, which makes the shorting even more awful. And you have a pernicious positive feedback cycle that increases the temperature inside the battery until you get to the auto ignition temperature. It turns out that the lithium ion battery can catch fire without the presence of oxygen from outside the battery, from ambient air. Now, as the fire gets going, eventually the housing of the battery is breached. As soon as that happens, you have a source of additional oxygen from the outside air that substantially accelerates the fire. It's one of the reasons that it's so difficult to put out a lithium ion rechargeable battery fire. So whether you have one or two people on the emergency response team at your facility, or a 10-person team or a 20-person team, or emergency responders that are just there for general response purposes, those teams, most of them are already very focused on HF as a hazard because they read about it, they hear about it every day within the emergency responder community. Sometimes you have the presence of cyanide, sometimes it's phosphine. At chemical plants where you're manufacturing insecticides or precursor compounds that are chemicals that are used to make organophosphates. You might have methyl mercaptan, mesh. Mesh is very similar to H2S. It is a kind of sulfide, but if you're waiting for an H2S sensor to respond to methyl mercaptan, it ain't going to necessarily happen. So if you have it, you need to measure it more directly with a different sensor. Sometimes, since the mesh is a fellow traveler with the H2S at that part of the facility, it's one of those combinations that is like in Forrest Gump. Mesh and H2S go together like peas and carrots, which is why there is a very nice application for many specific two-sensor combinations in a compact personal instrument. And this is only the beginning. At GFG, we make most of our own sensors. We have an entire sensor manufacturing division in Germany. So we have an unusually wide and diverse array of toxic gas sensors. So if you have an oddball or normal for you need, give us a call. We might be able to help you. This would be a picture of the two gas instrument. This we call the 222. Whatever brand of two gas instrument that you are looking at, there are some combinations that come up over and over for NOx, oxides of nitrogen. A really good combination is a two gas meter for NO and NO2. For fire departments, after the visible flames are gone and the visible smoke from the fire ground has stopped being emitted, that stage of the fire response is referred to as overhaul. During overhaul, you need to measure both CO and cyanide and make sure that you're below exposure limits before you allow the emergency responders to remove their SCBA masks. CO and HF, as I've already mentioned, HF from the lithium ion batteries, huge concern, and it goes into a two sensor instrument with a CO sensor very nicely. H2S and SO2, H2S and mercaptan. There are a bunch of combinations where this is a really good approach. And take HF very seriously. You don't have to have an actively burning battery to have the presence of a high concentration of extremely toxic gases. As the battery starts to heat, you can get to the point where at early stages of thermal runaway, this feedback loop has heated the battery. You haven't quite burst into flame, but you're already starting to off-gas all sorts of horrible toxic gases and vapors. So if you deal with lithium-ion batteries, make sure that your monitoring program includes instruments with the sensors that you need to use to keep safe. You also have the presence often of hydrogen, you have the presence of sulfides. Lithium ion batteries, for something that we use every day and that most of you have in your pocket right now in the form of a cell phone, and that I'm looking at in the form of my laptop sitting on my desk at the moment. Lithium ion batteries are everywhere, but there is a reason why there are prohibitions about checking a cell phone when you fly somewhere in your luggage. As everyone who's listened to the flight attendants know, you're not even supposed to put lithium ion rechargeable battery equipment in the overhead bin. You're supposed to leave it right at your feet where you can get at it if it starts to misbehave. So take HF seriously. Gas detection requirements are definitely not only limited to the use of portable instruments. Sometimes it's a better approach to have fixed monitoring systems where the sensors are in a housing, the housing is mounted on the wall, and the operation is 24 hours a day. when the activity is covered by permits, it's not going on 24 hours a day. In that case, like confined space entry or personal protective instruments that are issued to everybody on site, portable instruments make the most sense. But if you have areas where entry is not governed by permits, where the hazards could be present at any time, a fixed detection system is probably the preferable solution. And it's not a zero-sum game. Just because you have a bunch of or reliance on portables does not mean that you don't also need a fixed detection system. It's belt and suspenders, the two kinds of instruments and instrumentation systems go together. Don't be afraid of considering fixed system solutions. Many fixed systems are small, standalone, one or two or three or four sensor systems, which are very easy to specify, easy to install, easy to work with and calibrate. They're not dangerously complicated. Figuring out what you need can be intimidating. Try to get your partners involved in the process. Specialist salespeople that work for your distributors are one good source of expertise. Manufacturers are an even better source. If you can beat your way through the telephone system to get to a knowledgeable person, they can really cut through a lot of the difficulties in coming up with a good system. And of course, all of the manufacturers, just like GFG, have tools like this simple questionnaire. You start out by filling out the questionnaire as best you can. The more information that the manufacturer has, the better job we can do when it comes to providing you with a quote. The reason we need some information is we have so many options. A fixed system, almost by definition, is going to be a customized system that is designed and configured exactly for you, not for another customer just down the street. The first step is to figure out what needs to be measured. The sensor is housed in what we call the gas transmitter. That's the sensor plus the localized electronics that provides power to the sensor and interprets the signal. You can have a display, you can have what we call a blind transmitter, you can have local alarms, sirens, horns, and on lights. You can have anything you want on a local basis, or you can wire or transmit the information back to a controller or a computer or a programmable logic computer, a PLC. You can organize the system any way that makes sense. In areas which are characterized by the presence of potentially combustible atmosphere, then you're going to need to install those sensors in explosion-proof housings or intrinsically safe housings so that they can actually be in the area. Sometimes you want the sensor on a cable, sometimes you want the equipment to include a motorized pump that sucks the sample from a remote location back to the housing where the sensor is located. Sometimes you just want the sensor installed in the detector housing, operating in diffusion mode. But these are all options that need to be explored. The easiest way to explore them is with that questionnaire. Once you've filled out the questionnaire, now it's a lot easier for the manufacturer to offer the best solution. What you don't want to do is buy it one way, realize that nope, if you remember the old commercial, if you're old enough, there was a great commercial for V8 vegetable juice, and people would think about V8 later, and the tagline was, "Oops, I could have had a V8." So you don't want to have that V8 moment after you've invested $10,000 into a system that should have been brought in with a slightly different configuration. You also have many options when it comes to how you integrate the system. You can integrate the system the old-fashioned way with 4 to 20 milliamp wiring. You can use wireless transmission. You can use Modbus digital connection. There's a lot of ways that you can go. But the idea, especially with your fixed detection system, is whatever information you need, you make sure you have it at the right place at the right time. And here we have one of my favorite characters from Breaking Bad, Hugo Salamanca, who's a really bad guy. And this is the famous moment where Walter is showing him the blue product for the first time. And of course, with GFG, our product is blue, not deadly blue, excellent blue that protects workers, but blue is blue. And I'm sure that Tuco would have found something wrong with our color scheme also. But given our color scheme, given our sensors, given our technology, we have a lengthy list of over 500 gases and vapors that we can detect. So, and again, a lot of the reason that we have such a wide range of gas detection products is we control the sensor technology that we use. And we're very proud of the quality of our sensors. For instance, what about the LEL sensor? I already mentioned that some kinds of LEL sensors are good for hydrogen. Sometimes the sensor is not equipped for able to detect hydrogen. So when we are talking about fixed, when we are talking about portables, we always discuss the hazards, and we will fit the configuration that we suggest to the hazards that you actually are dealing with. Traditional catalytic sensors detect the gas by, in effect, burning the gas. They catalytically oxidize the gas, which causes an increase in temperature within the sensor, which is proportional to the concentration. That kind of sensor is very common. We use it all the time, preferentially. It's a great sensor. It has some limitations. The sensor can be poisoned, especially by silicone containing substances or vapors. Also, it can be harmed by methanol and other alcohols and sulfides. So in a lot of cases, we're going to avoid using that sensor. And instead of a catalytic sensor, we'll use an IR sensor. We make our own IR sensors. We are very proud of our patented IR LEL sensor technology. We often build a 2-in-1 sensor that includes IR LEL as well as IR CO2 measurement. So we've got a lot of different capabilities. And with each of these sensors, you need to talk them through with someone who understands. No type of sensor is perfect for every conceivable application. There are always pluses and minuses, and the way that you find out what those are is by asking questions. For instance, a primary advantage of the IR LEL sensor is you don't need oxygen in order to have the operation of a sensor. With the catalytic LEL sensors, you can't really use it in an inerted vessel because it requires the presence of at least 10% oxygen in the atmosphere for the sensor to work. PID is another company specialty. PID is the kind of sensor that you use for volatile organic chemical vapors, VOC vapors. VOC vapors are pervasive in the chemical industry, and although VOC vapors are explosive, they are toxic at much lower concentrations. Every single VOC in the NIOSH guidebook hits the toxic threshold long before you even get to 5% LEL. So if you're trying to get by using a combustible meter for VOCs, it's a terrible idea. There are lots of new things going on in gas detection. It's a very active, innovative industry at the moment. And it's hard to keep track of all the new stuff that is available. That's the role of your suppliers, distributors, specialists, salespeople, especially ones from our AD affiliated distributor family, are very knowledgeable. They sell a lot of gas detection equipment. And even if they don't personally have the answer, they know where to go to get you the answer that you need. Once again, start by looking into your own operations. Find out, figure out what you are using now throughout the organization. Find out from the people who use it within your organization, how is it working? What are the current capabilities that you have? Or what do you need to improve? What do the guys who are using the equipment say they need and would like you to think about in the future? Excuse me. I will let you, speaking of gap analysis, I will let you guys gap that out later. So, what are you using now and how is it working? Important questions to ask. Are you generally happy? Meaning, are your employees generally happy? Are you having problems? How old is the current equipment? What features have you heard about that you are interested in? What are the brands and models that you are considering or that you have heard about? What are the alternatives? Again, distributors are a valuable source and conduit of information. Even if you think you know what everyone has to say, ask. Trust but verify. This is the critical starting point in the conversation. You really want to find out the problems that are going on before you bring in something different. And this, again, another of my favorite Breaking Bad moments. I was just wondering where Gail is. Gail is the brilliant chemist who also did not make it through the end of the series. Jesse took care of him to save Walter. Avoid being overly focused on price. The decision eventually comes down to price, but it's better if you figure out what you need, what the trade-offs in cost and performance are, before you get completely focused only on price. Um, and remember Walter's words of wisdom. Don't settle for some tepid off-brand generic cola. There's a difference between the initial purchase price and the highest value proposition or cost of ownership over the life of the instrument. So sometimes the most cost effective solution might have the higher initial purchase price. Put that or bring that into the uh, investigation by identifying your cost of ownership issues. Are you being charged a monthly fee? Can you trust your current gas detectors? Do you have a lot of sensor or battery failures? How often do you test and calibrate your instruments? And how tough is that? Do you do it yourself or use a service? Do you feel like you're getting a good deal? Make sure you think about how you're looking after your instruments, and you don't want um, an unqualified individual that is maintaining the equipment in a shoddy manner and putting you at risk. Once again, that's one of the reasons I'm so proud of being part of the AD network. If you are using a vendor, an AD distributor who has a qualified factory authorized service department, you know that the guy who is working on your instruments is not Badger, who, as you might recall, is the designated idiot in Breaking Bad. I have always loved that "say my name" moment with Walter. So just to be able to say their names, these are the two leaders of our service department at GFG. The individual to the front is Steve Kroc, if any of you have called up with a service related question. The dapper guy towards the back is Paul Rolston, who specializes in our fixed detection system, equipment, and questions. These guys have nothing better to do in their lives, at least while they're on company premises, than answer customer questions. Make sure if you're thinking about confined space instruments that you consider how you're going to sample the air in the confined space. You have more than one alternative. My favorite alternative is to have a built-in pump, but to be able to switch the pump on and off as needed. And batteries. Batteries are important, as some of you might remember from this episode. You don't want to run out of power in a remote location where the absence of a functional battery can put everything at great risk. And finally, who doesn't love Los Pollos Hermanos chicken? In our case, I would say we have the finest gas detection ingredients, which are brought together with love and care. And actually, that's kind of funny, but we're serious about that. The quality of the gas detection product is certainly even more important than the quality of Los Pollos Hermanos fried chicken. And we have a lot of information on our website that can help you decide why our instruments are the world's most tasty and have the best ingredients. We not only have a decent price for our products, but we take support of our customers very seriously, as do our AD distribution partners. We're here to answer questions. We hope that you will call us up and ask for help. We are at your second call at your disposal. And thanks for your attention, and I hope you enjoyed the presentation. Bye-bye.
Well, hey, thank you. Thank you, Bob. Always educational and entertaining at the same time. Should have had some spoiler alerts at the beginning of the presentation, but again, thank you, Bob. Thank you, GFG. Thank you, AD Safety Network, for continuing to support the safety profession by providing really deep educational content. We'll have Bob's coordinates in the description below, so if you want to reach out and ask him some questions directly, you'll be able to do that. Again, thank you so much for joining us, and thank you to Bob and the team at GFG.
Thank you, Scott, and make sure that nobody on your team winds up like Tuco.
We'll do our best. We'll do our best. Thank you so much, Bob.
Bye-bye.